We are in section 5.2, integration by substitution. One of the most common methods of integration is called substitution method, or use substitution, or just even use sub. We can think about it as the chain rule in reverse, or the method for undoing the chain rule. So the chain rule was, remember, the derivative of the outside keeping the inside function the same times the derivative of the inside. And so we have what's called the substitution rule. And this is going to be the integral of f prime of g of x times g prime of x dx is just equal to the integral of f of u du, where u is equal to that inside function g of x and is a differentiable function whose range is the interval I and f is continuous on that interval I. Integration by substitution, or the unchain rule. Notice the problem is a composite function, or a composition function where there's an inside and an outside function. First thing to do is identify the inside function. The inside function we're going to set equal to u. So step 2 says find du from u, and we get that by taking the derivative of u with respect to x. And then we're going to solve for dx. Substitute u and dx into the original problem. Simplify. 5 says integrate, 6 is back sub in for u into the solution, and 7 is to check by taking the derivative of the solution. So I took those steps and wrote them down for the problem for the first two, just so we can kind of get a better understanding of the steps to do this. So example says find the integral of 8x times 4x squared plus 1 raised to the 5th power. And so for this, you'll notice that we do have an inside function. That inside function, again, is in parentheses, like we saw when we talked about the chain rule. And so remember, the inside function is what we're going to set u equal to. So I'm going to set u equal to 4x squared plus 1. So now this means my integral is going to be the integral of 8x u raised to the 5th power dx. And so next thing I'm going to do is differentiate. So this was u equals 4x squared plus 1. So I'm going to take the derivative of u with respect to x. And taking the derivative of 4x squared plus 1, we get 8x. And so multiplying both sides by dx, we can rewrite this as du is equal to 8x dx. And then it says, and then solve for dx. And so to do that, we're going to divide both sides by 8x. And so we have dx is equal to du over 8x. And we're going to substitute that in for dx. And so substituting that in, we have the integral of 8x times u to the 5th. And instead of dx, I'm going to rewrite that as du over 8x. And so one of the things we talked about with integration is that you can only have one variable in it at this point of time. And so that variable that we have right now, if you notice, we have u's and we have x's. But if we were to simplify this, you'll notice that your x's actually reduce out. And this is going to simplify to the integral of u to the 5th du. And we can easily integrate this. So next step says to integrate, and don't forget your plus c. So the integral of u to the 5th is going to equal 1 over 6 u to the 6th plus c. The next step says to back substitute in u equals, remember u from up above is 4x squared plus 1. And the reason why we do this is because our original problem is in terms of x's, and right now we have it in terms of u's. So from here, we're going to get 1 over 6, 4x squared plus 1 raised to the 6th power plus c. And so the last thing to do is to check. And to check, we take the derivative. And so 1/6 times 6, using that power rule, and keeping that inside function the same by the chain rule, times the derivative of the inside, which would be 8x. And then the derivative of c is just going to be 0. You'll notice that your 6's are going to reduce, and we end up with 8x times 4x squared plus 1 raised to the 5th power, which checks. That was what we were given up above. So we have another example on the next page, and this one says find the integral of x plus 1 over 4x squared plus 8x raised to the third power. And so the first thing we're going to do is let u equal the inside function. And so this time the inside function is in the denominator. And so we're going to let u equal 4x squared plus 8x. And again, that is in the parentheses, but in the denominator. And then we're going to take the derivative of u with respect to x, so du dx is going to equal 8x plus 8. From here, I'm going to multiply both sides again by that dx, and I'm also going to factor out the 8. So I have du equals 8 times x plus 1 times dx, and again, we got that by multiplying both sides by that dx. And then solving for dx, I'm going to divide both sides by 8 parentheses x plus 1. So we get du over 8x plus 1. And now we're going to substitute this in. So the first thing that I notice is that we're going to have the integral of x plus 1 over u to the third dx. And then from here, I'm going to substitute in what dx is. And we got dx is equal to du over 8 parentheses x plus 1. And so now we have x plus 1 over u cubed times, and instead of dx, I'm going to write du over 8x plus 1. And again, you'll notice that this simplifies, and your x's plus 1 are going to reduce out. The 8 that's in the denominator, or the 1/8 that we have, you can pull out in front of your integral. It's just a constant. And I'm going to rewrite it as u to the negative third du. The big thing to note here is that we've removed all the x's, and our integral is now written in just in terms of u. And so now integrating this, we have the 1/8, which is just our constant, times, and then we're going to add 1 to the exponent and then also divide by that same value. So u to the negative second over negative 2 plus our constant c. Cleaning this up a little bit, this is the same thing as negative 1 over 16u squared plus c. And then the next thing is to integrate, which we just did, and then back sub in u equals. So we know that u is equal to 4x squared plus 8x, and I'm going to back sub that in. So we have negative 1 over 16, and then instead of u, we're going to put 4x squared plus 8x to the second plus c. So that is our integral that we just arrived at. And we can check this by taking the derivative. And so in order to do that, I'm going to rewrite my original problem that I have up above, my answer, negative 1/16 times 4x squared plus 8x to the negative second plus c. And now taking the derivative of this using the chain rule, we're going to have negative 1/16 times negative 2, and then keep that inside function the same. Subtracting 1 from your exponent, so now we're back at our negative 3, times the derivative of the inside, which would be 8x plus 8. Derivative of c is just 0. And then again from here, just simplifying this, so you'll notice that your negatives would cancel, your 2 and your 16 would cancel, and that would become an 8. I also notice that I can factor out an 8 over here, and so I get 1/8 times 8, I'll put that out in front, x plus 1, and then the 4x squared plus 8x to the negative third. And so rewriting this, your 8's can cancel, and you end up with x plus 1 in the numerator, and then in the denominator, moving that down, we get 4x squared plus 8x to the third. And that checks with the original problem that we were starting with up above. The example right below says find the integral of x plus 3 over x squared plus 6x dx. And we are going to use u substitution. And the reason why we know this is because if you think about all the different techniques that we have for integration, which are not very many, we had some rules that dealt with logarithms or exponentials, and we also had our power rule. But we don't have anything in regards to the quotient rule or the product rule like we saw with taking derivatives. There isn't any rules for those. So with that said, I need to think about what to set our u equal to since I have no other way of doing this problem. And so I'm going to let u equal, and I'm going to try the denominator. And a lot of times you'll try things and then it won't work. But the reason why I'm going to pick this for my u is that I notice that the derivative of x squared plus 6x is going to be 2x plus 6, which if you factored out the 2 would equal the numerator. So next step I'm going to do is take the derivative, so I have du dx equals 2x plus 6, which again, like I said, if you factor out the 2 and multiply both sides by dx, I get du equals 2 times x plus 3 dx, or we get dx is equal to du over 2x plus 3. From here, I'm going to substitute in u and also dx. So from here, we get our integral is going to be x plus 3 over the denominator, which we called u, times, and then instead of dx, I'm going to write du over 2 parentheses x plus 3. From here, you'll notice those x plus 3's reduce out. You do have a 2 in the denominator, or a 1/2, and we could put that out in front. And we have 1 over u du. And so now integrating 1 over u du is going to be the natural log of the absolute value of u. And then also don't forget to add your plus c. From here, you'll notice that your answer has u's. However, our typed problem has x's, so make sure you never forget to back substitute in what u is. And so instead of u, I'm going to write x squared plus 6x. So this is equal to 1/2 ln of the absolute value of x squared plus 6x plus c. The example right next to this one says to integrate x cubed e x to the 4th dx. And so for this, you'll notice that we don't have any rules to integrate anything with multiplication. So for this one, I'm going to let u equal, and I'm going to try the exponent, which is x to the 4th. And you'll notice the derivative of x to the 4th is 4x to the 3rd. So I notice that x to the 3rd also in the problem. So I'm going to let u equal x to the 4th, taking the derivative. And I'm going to kind of take the derivative and multiply also by that dx at the same time. So this is the same thing as saying du is equal to 4x cubed dx. Saves you one step, but if you didn't like that other one where you had written du dx, you definitely can still do that. And then making sure I solve for dx, I'm going to get dx is equal to du divided by 4x cubed. So the next thing I'm going to do is substitute in u and also substitute in dx. So this is going to equal the integral of x to the 3rd e to the u times dx, which is going to be du over 4x to the 3rd. From here, you'll notice that your x to the 3rds will reduce out. So the 1/4 we can pull out in front of our integral and have the integral of e to the u du. And so integrating e to the u, we just get e to the u. And then don't forget to add your plus c. And then again, back subbing because we don't want to have our answer in terms of u. And we get 1/4 e to the, and u is equal to x to the 4th plus c. And so again, this is your answer. However, you can also check. And to check this, just to show one of them, I'm going to have 1/4 e x to the 4th times that derivative of the exponent, which is 4x to the 3rd plus 0. Your 4's would reduce, and you'll notice that you get x to the 3rd e x to the 4th, which checks with the original integrand that we had up above. The example on the next page says find the integral of 1 plus 5 ln of x squared all over x dx. For this problem, I noticed that we do have an inside function, and I also noticed that with my inside function I have ln of x, which the derivative of ln of x is 1 over x, which is also left over with my function. So I'm going to let u equal my inside function, which is 1 plus 5 ln of x. And then we know that du is equal to 5 over x dx. Or multiplied by the reciprocal, we get that dx is equal to x over 5 du. So now I'm going to substitute this into my integral, and I get the integral of u squared all over x times, and then instead of dx, I'm going to put x over 5 du. From here, my x's are going to reduce out, and so I'm going to end up with 1/5, which I can move out into the front, the integral of u squared du. And again, the big thing to note here is that I have removed all the x's and I've substituted in u's and du, and so now I can take the integral of this with respect to u. And so we have 1/5 times 1/3 u cubed, adding 1 and dividing by that same value, plus our constant c. I can simplify this to 1/15 u cubed plus c. But from here, you must not forget that you need to back sub in what u is, and we defined u up above. So we get 1/15 u, which is 1 plus 5 ln of x to the 3rd power plus c. And again, for this, we can check by taking the derivative, so definitely something you want to try to do on your own. And also good to note for taking exams, a way to check your answers. The example right next to this one, I'm going to go ahead and circle, and we're going to look at this one together in class. The next example I'm also going to circle, and we'll look at that one together in class. So looking at that bottom right example together on page 6, it says find the integral of 4t times the square root of 8 minus t dt. And so for this, I notice that I do have an inside function, so I'm going to let u equal 8 minus t, and then taking my derivative with respect to t this time, I get du equals negative 1 dt, or you can think about this as dt is equal to negative du. So from here, I'm going to substitute these in, and I get the integral of 4t times the square root of u, since 8 minus t was equal to u. I'm going to put the negative out in front of my integral, so I have negative and then a du. And noticing this though, nothing reduces with that t variable that we have that's out in front of the radical. So right now I am left over with the t, and I'm not able to integrate it like this. So don't start integrating yet. We're stuck, we have a problem, and this is going to arise quite often with these. And so we need to think of a way to rewrite t in terms of u. So in order to do that, I'm going to look at what I chose for u equals. And I noticed that with that, I could rewrite this in terms of t. So let's say I have u equals 8 minus t. So I can add t on both sides, and I get t plus u equals 8. And then I could subtract u on both sides just so I can get t by itself. And I get t is equal to 8 minus u. So I can substitute this in for the t that I am left over with in my integral. So I have negative, I'm going to pull the 4 out also. And then instead of t, I'm going to write 8 minus u. And then instead of the square root of u, I'm going to write u to the 1/2 du. So from here, I notice that we have an integrand that has all u's. We were able to get rid of that t, so I'm able to integrate it. However, right now I'm still multiplying two things together, and we don't have a product rule. But I can fix that by distributing my u to the 1/2. So I get negative 4, the integral of 8u to the 1/2 minus u to the 3/2 du. Now from here I can use that power rule and integrate this. and so we're going to have the negative 4 that stays out in front. I have 8 times, and then from here it's going to be adding 1 to that exponent. So that's going to be u to the 3 over 2. And then multiplying or dividing, I can say if you divide by the same thing, it's the same as multiplying by that reciprocal. Minus adding 1 to my exponent here, I get u to the 5 over 2. And then again, dividing by 5 over 2, or equivalently, that would be multiplying by the reciprocal of 2/5. Don't forget your plus c. From here, we just need to kind of clean this up a little bit. So we would have multiplying this negative 4 into both of these terms. We get 8 times 2, which is 16, times the negative 4, which is negative 64 over 3, u to the 3 over 2, minus, and that negative times the negative would actually make this become a plus, and we end up with 2 times 4, which is 8 over 5, u to the 5 over 2, plus c. And then rewriting this in terms of radicals and instead of rational exponents, I'm going to have negative 64 over 3, the square root of u cubed, plus 8 over 5, the square root of u to the 5th, plus c. From here, we need to back substitute in what u is equal to. And so up above, u is equal to 8 minus t. So every time I see a u, I'm going to put 8 minus t. So we have negative 64 over 3, the square root 8 minus t to the 3rd, plus 8 over 5, the square root of 8 minus t to the 5th, plus c. And this would be our final answer. Always make sure your answer is written in the terms of the original problem, and this problem was in terms of t, so make sure that you back substitute in whatever you had set for u so that your final answer is in that original variable. The example on the next page says the resale value of a certain industrial machine decreases at a rate that depends on the age. When the machine is t years old, the rate at which that value is changing is negative 960 e to the negative t over $5 per year. Express the value of the machine in terms of age and initial value. So first thing I note is that this is a rate. And that means that if it's a rate, it's a derivative that we are dealing with. Also note that I'm dealing with t, which is in years. So part A says express the value of the machine in terms of its age and its initial value. So with that, I need to find a formula that's going to represent that value in terms of time or years. And right now I have a rate, so it's a derivative function. So in order to get that original function, I'm going to need to integrate that rate, which was negative 960 e to the negative t over 5. And I'm integrating this with respect to time, so t. So in order to do this, I'm going to go ahead and pull the negative 960 out. And I have e to the negative t over 5 dt, which I'm unable to integrate like this. And so we have an inside function, which is that exponent. So I'm going to let u equal negative t over 5. Or if you want to think about it as negative 1/5 times t, same thing. So taking the derivative of this, I get just negative 1/5 dt, or dt is equal to negative 5 du. So from here, I'm going to substitute that in. I have the negative 960. The integral of e to the negative t over 5 is just going to become e to the u. And then dt is the same as negative 5 du. So multiplying negative 5 times negative 960, we get 4,800 times the integral of e to the u, du, which is luckily nice to integrate. Right now we only have u's in our integrand, and we're integrating with respect to u, so that works out perfectly. So we have 4,800 e to the u plus c. And with this, we need a back sub in, so we get 4,800 e to the negative t over 5 plus c. And so the question was asking to express the value of the machine in terms of age and initial value. And so this would be our value function. I'll call that v. Part B says if the machine was originally worth $5,200, how much will it be worth in the next 10 years? So when it's 10 years old. So it was originally worth $5,200. So that would be when time is equal to 0, since that's the original. And our value was $5,200. So substituting this into my equation that we just found, which I'll rewrite, I'm going to put in the value of 5,200 e to the negative 0 over 5 plus c. So e to the 0 would just be 1. So we get 5,200 equals 4,800 plus c. And then solving this, subtracting the 4,800, we get c is equal to 400. So our value equation that we have is v equals, and it's 4,800 e to the negative t over 5 plus c, which is 400. And so from here it says how much is it going to be worth when it's 10 years old. So when it's 10 years old, since we're dealing with years here, t would be equal to 10. So substituting in t is 10, we get 4,800 e to the negative 10 over 5 plus 400. So v is equal to 4,800 e to the negative second plus 400. From here I would substitute this into my calculator, solve this, and round 2 decimal places since we are dealing with money. And so when you work this out, we get 1,049.61. So this is a dollar amount that it will be worth when it's 10 years old is going to be $1,049.61.